So let's talk about time series fitting. So that's a good segue. So time series fitting, what it is? Well, it was pioneered by the Census Bureau. They had the X10 program in the 60s and the X11, and it would deseasonalize the numbers. It would do exponential smoothing, and it would apply various methods. And using various statistical calculations, it would tell you, well, this is the just like we did with the curve fitting. It would tell you which model tends to approximate the historical data the best. Now, again, does that tell us which will it be good? Will it be as good in the future as it was in the past? We don't know. So it was used to test the forecasting models and to try and figure out which was the better predictor. And, of course, the other thing that was really useful, because you have to remember that in the 1960s and 70s, a lot of this stuff was coded, and it was a lot of very labor-intensive producing these kinds of analytics. Analytics in themselves are not new. Companies have been doing Monte Carlo simulation and forecasting and advanced time series for 50 years. What has changed over time is the cost and the energy. So you could even apply a learning curve, on what it costs to do analytics today. So that's why it's become much more accessible to a lot of people, and more people can do these things. So that's why you guys, like I said, you need to be you really need to be able to look at the to use these tools to your advantage, and Excel and At Risk really do contribute to this. Some of the tools that we could look at is that when you take your forecast and you back test it, you could also use mean absolute percentage error. So you're basically looking at the accuracy of a fitted time series in terms of statistics with trending. And we've included the formula. All these methods are well covered in Wikipedia, or my favorite learning instructor, Master Google. Another one is mean squared error. So what do these things do? You just need to slow down, and so they take the mean and the value that you project, and it looks at the error, and it does a square root of that. And as you know, when you're doing fitting using estimators, but you're trying to figure out the variance within that. It's also very good because it works at a level where randomness is used. Mean absolute deviation, it's a simple, you actually have an Excel function for it. And all it does is that it looks at each data point, and it looks at the difference that it has against the arithmetic mean. It's a very simple process. So we talked about back testing. So why would you do this? Well, you pick a forecasting method. You slide back halfway to a midpoint in your data, and then you see if that process, if you used it using the previous data and you tried forecasting forward, would that make sense? Sometimes it doesn't. And a really interesting thing is that what they've seen is over time, even though you might have these very sophisticated methods, exponential smoothing over time tends to do better than a lot of other methods. So as we mentioned, if you're backtesting, it might work. It might not be a good predictor of the future because it was operating under the assumptions in the data that you had, 6 years ago, looking forward 3 years ahead. So things may have changed at that point. So how about integrating expert judgment? So we come off to our second of three models today, and we are going to look at so I'm just taking a second to read an interesting question. Okay, so, and we can always talk about this offline, but I will try to. So you work at a power company, and you have 10 years of historical data, and you want to project 10 years out. What's going to happen is that there's a lot of information that's going to come in using the trends in terms of consumption, There's going to be a lot of econometric data that's going to go in there. So if, for example, if you look at the adoption rates of electronics in the household, and that you see that, 10 years ago, people had one, 2 TVs, a computer, and so on. And maybe based on the economic development happening in your region, that this is changing. So now they have routers, phones, this, that, and just the sheer number of things that are plugged in. I also am aware that in the Middle East, they're pilot testing electrical car programs, which means that might have an added impact on the grid, which is something that you guys need to plan and build out. So if these are things that, if this kind of makes sense to you, I'd be happy to discuss this, and then we can also look at how you would incorporate your historical data on the usage and then use that trending and so on. So I hope that that helps. Fantastic. Good. So let's just close this. Of course, we'll save just because sorry, at risk, we don't need the data. And now we're going to go into here, and we are going to pull up our power curve forecast. And I think a lot of people are going to appreciate this, because sometimes we often have to get guidance in a business about what we think is going to happen. And kind of like the case that we were talking with Yaya, maybe you go out to the business and you get guidance, or you have some of these things. What we have here is our forecast. So coming back to the same historical data we used, we have our mining, energy, forestry, and agriculture. So for you Excel fiends, okay, this is is no more than a validation, and here we use an index match. So it pulls out the mean and the volatility, calculates the P5 and the P95 for 3 points at 12 months, which you see here, 36 months over here, and 60 months over here. So it's 3 points, and that should enable us to create some curves. And so let's put this on the expected values for a second, and that gives us this really smooth thing. So we know that we were able to calculate what these values would be. So P95, and when we turn the expected value, we know that this is right here basically a random walk. So, but we see that there's an implied trend that over time the negative returns will go away, and that maybe there won't be as significant an increase in the upper bound. So let's have some fun with this. So the first thing that I would like to show you guys is that you can use Solver or Risk Optimizer. In this case, I use Solver because it was already kind of set up that way. So my apologies to the at-risk crowd. But where is it? There we go. You see, I don't use it that often, can't even find it. So essentially what we're looking at is that we have over here these red boxes are to be optimized. And what it's going to do is that it's going to attempt to shape the curves in the most appropriate way possible. So to give you a sense of what that looks like, I'm going to just scan over here, and we're going to hit data. I got a question. So Solver is part of Excel. Okay, so it's standard. You just need to install it as an add-in along with your data analysis tool pack. So this, of course, however, there is a larger version of Solver out there, but the one we're working with is Excel. So coming back over here, so we picked the commodity, and we are just going to hit solve, and we're going to use a nonlinear solve. And what we can see is this is one scenario. This is another scenario. Here's another one. So you can see that uncertainty goes out and increases over time. And here's another scenario. And then we'll just keep that because we like the way that it fitted it. But say we wanted to adjust this. So we're like, okay, this is cool. So we have our base curve set up. We set up these sliders. So first thing we did is that we can inverse the sign, so it will multiply it by -1, and look what happens to the curves. So just by applying inversions, we can just start changing the pattern of what? So now we've noticed that the direction went from going up to now it's going down. Let's try this. So see, if we inversed the lower bound pattern, we can see that we're getting very different. And we have done, and here's another type of pattern where the risk would go in reduction over time. So these are all different time series. And if I ran this, if I hit F9, you can see what the index forecast would look like. You can see that it gives it a very different pattern. So it's not too volatile here. And let's take some of these inversions out. Whoops, that doesn't work. There we go. And if we hit F9, we can see that with the returns we're getting, a various, so these are fairly stable numbers. We can change this and go into energy and have it refit again. So we'll go back, developer, data, solver, and we'll solve it again, and we'll see that it'll come up with different patterns. Now, I've left a few things that are inversed, so that's why things kind of, and look at this. We even have a fish. And we'll just stop that, and we'll say, yeah, that's the one I want. Okay. And so this is a very unique way and a very powerful way of getting your expert's opinion, and then they can just use their sliders over here. They don't just have to use, see, we can even have it change over there and reshape the curve, take it off the inverse, add that, and here we can even pull that, see, like so. And this is an extremely powerful and useful technique, and it enables you, and all of these, just so you guys know, it is all form in Excel. It's easy stuff to do. You just use the developer tab, and they are form controls. They will manipulate here. So you can configure these just so you can see how they do it. So we did that with the inverse, and we created all the math around this. And as you can see, with this type of forecast, you'll see that the pattern for the index forecast has changed significantly against what we were looking at previously, which was just humming around here. So we've created a far more volatile forecast just by adjusting the sliders than we did initially. So, does anybody have any questions? And by the way, coming back to this is a simple GBM because we've modeled independently each set of returns. So we're getting a question that people are using historical data and to project out forward, and now they've had, okay, I see. So, and now they've had the financial crisis, and what do they do after that? So, coming back to the financial crisis, and we were talking, and this is a good segue back to my PowerPoint. So if we were looking back over here, we talked about the components of a time series, right? And within that, you have cyclicity. And the other thing that you should be thinking about is the horizon. You remember, so if in 2005 or 2007, if you looked at how that period correlates with now, so you would look, 3 or 4 years, and you would see how each data set correlates amongst each other, you might notice that you might not correlate anymore with what happened in 2000. Now, a lot of the historical methods that project short term, like ARIMA and some of these mean reverting autoregressive processes, are very good to forecast maybe 12 months out, 24 months out, 36 at the utmost. But after that, those methods are useless. Okay, so that's why to filter out for outliers, and that's why we talk about recording the circumstances of the data. So you can there are certain ways to account for that. Say, oh, well, this happened, but it is a cyclical event and not a seasonal or a trend. And a mean reverting process means that even if you have a spike over time, you will over time you'll turn back, you'll come back to some sort of natural average. That's why if you look at the stock market over the last 50 years, you've had like a 4 or 5% growth. Even though the market has gone up and down in very violent ways. And in fact, if you had invested, $10,000 in 1966 in the Dow Jones, you wouldn't have seen a return you would have made a very modest return by 1989. You would have barely recovered your money. However, if you had invested from 1999 to 2000, you would have made phenomenal returns. That's why we need to look at having various forecast horizons, a short-term, a medium-term, and a long-term forecast. Anyways, if anybody wants to talk about this further, we can talk about it offline. So